Here, I want to look at this guy. Yeah, it's no big deal. We did stuff like this yesterday. So if we want to solve a polynomial equation like this, what do we do now? We're thinking back to chapter 5 stuff, right? When we solved quadratic equations, what did we always do first? Set them equal to 0, right? We got to set it equal to 0. Okay. So to do that, we'll add 16x to both sides. So we get okay.
Take out a 2x.
Okay, good. Now what? Yeah, we got to factor this thing, right? Now, we don't have, before, in chapter 5, we had the option of just using quadratic formula, maybe, and getting an answer. We didn't really have to do a lot. We would factor if we wanted to, but we don't have that anymore. Now we have to factor. If we want to get answers out of this, we got to break it apart into pieces, and then set the pieces equal to 0, right? The factors. So, always we want to see if we can factor out a greatest common factor. Trevor, what did you see there?
2x.
2x. 2x, I can pull a 2x out of each term. 2 divides into each of those coefficients, and then I can take an x out of each term also. So we'll pull out that 2x, leaving us with what? X to the 4th, right? Because 2x times x to the 4th would give us x to the 5th. Minus, good, 6x squared plus 8, okay? All right, so now, so far so good, but we need to do more with this. We've got this still pretty big, ugly polynomial, 4th degree polynomial. Now, if you look at this term right here, it's got, or this, excuse me, this factor, it's got 3 terms. What was our strategy we talked about yesterday for 3 terms? It was 2 terms, we had factoring patterns. 4 terms, we grouped, right? But if there are 3 terms, the only way we have to do this, what do you think, Brandon? Okay, good. Yeah, we're going to try to see if we can look at this, see if we can make this look like a quadratic form, like a chapter 5 type problem. So if we can take this stuff and rewrite it as something squared, in this case, minus 6 times something, in this case, plus 8. That looks like chapter 5 stuff, right? In chapter 5, those would have been x's. And then, right? But in chapter 6, they may not be x's. They may be something else. What would they be in this case? For that first term to look like something squared, what would that something have to be? X squared. For the second term to look like 6 times something, it's an x squared, right? So it looks like a chapter 5 trinomial, quadratic trinomial, but instead of having x's in here only, we've got x squares, but it works the same way, right? So if we break this apart then, if we break that apart and unfoil it, instead of, now first times first has to equal x squared squared, instead of just x squared. So instead of just having x's there, we have x squareds, right? And then just the magic numbers. What 2 numbers would multiply to positive 8? Negative 4, negative 2. Very good. And then out front, we can't forget we've still got this 2x. Okay? So now that whole thing is equal to 0. But don't lose sight of why are we doing this, right? We're factoring for a purpose. We're factoring to get this thing broken apart enough that we could set the individual factors equal to 0 and solve those equations easily. We couldn't have stopped. Now, obviously, at the very beginning, we have to do something. We broke it once, and that wasn't enough. The first one, maybe, sure, that one's done. But then this other factor was still too big. If I just set x to the 4th minus 6x squared plus 8 equal to 0, we don't have an answer yet. But once we break it apart again, Now we've broken it into 3 pieces. That's really enough, isn't it? Now if I set each of those 3 factors equal to 0, I get 3 small equations that are easy to deal with separately. Right? The first one, for example. If I set 2x equal to 0, what's x? If I solve for, 0, right? So one answer is x equals 0. Now, what if we set this equation equal to 0? X squared minus 4 equals 0. What do I do to solve for x in that equation? Add 4 and square root. Good. So if I add 4, I get x squared equals 4. Now, if I square root, I get x equals or positive 2, plus or minus 2, right? So I got 2 more solutions, right? And then over here, if I set this one equal to 0, what do I do to get the x by itself? Add 2, and then square root. So x equals plus or minus square root of 2. So how many total solutions do I get? No? 5. 1, 2, 3, 4, 5. 0 plus 2 minus 2 plus root 2 minus root 2. Okay? Now I could have. I had the option here. Some of you may have seen that this really is a difference of squares. That's x squared minus 2 squared. I could have broken that apart into x plus 2 and x minus 2. But why would I do that when that's just as easy to solve, right?
Does it really cross x-axis 5 times?
This one, yeah, it does. It really does. Yeah, a 5th degree, it turns 4 times. A 5th degree polynomial, as we'll see pretty soon, can have either 5 or 3 or 1 x-intercepts, and this one has 5. It really does cross 5 times. It's a very busy function. Yeah. Okay? Make sense? Okay. Let's go to 205.